Hi folks, Stuart again. Today we're going to talk about a very high level overview of authorization strategy and talk about some of the different types of alternative strategies you could have and what are the pros and cons of each, and sort of mechanically or from a design perspective how they work. So this is going to be part of a bigger series on identity and access management, which is a bigger part of security. There are lots of great channels out there that have really good security videos that I trust. But this series is not about the nuts and bolts of security or vulnerability testing or anything like that. It's more about, from an architecture and design point of view, what the different strategies are and practically when you'd want to use each one. And we're going to cover it sort of back to front, in that we're going to cover access management first as part of IAM. So we're going to give some definitions. So authentication is, who are you, right? If you've ever logged into anything, that's what you're doing. You're authenticating. And how do we know it's you? So, username and password, or certificate, or two-factor authentication with an app or a dongle or whatever. That's who you are. And it will come back with one or more identities for the set of proofs that are supplied. And in this slide deck, and just sort of generally in the literature, we refer to that as N, or authentication. And then authorization. Given that identity or identities, typically you pick one if you're an application. You say, well, of the different identities that come back with this, I know about this one. In fact, it's rare to have multiple identities, but it should be noted that almost all of the modern AuthN solutions will give you back an array of identities, and each identity has a number of attributes associated with that, depending on the protocol that's being used to give you back the information. Authorization, or AuthZ, is, what can you do? It's access management. So we've got some design goals. Basically, 5 different high-level design goals for any application system we're trying to build. They're fairly easy to understand, but they can lead to some subtleties. The pitfall, I will tell you right now, is that people try to implement something that is future-proof, and in so doing, they violate the Yagni rule, you ain't going to need it, and they add a lot of complexity to this subsystem in your application that may never ever be needed. From a goals point of view, you want to have a way of determining what a user can do with just a minimum of overhead and fuss. You want to be deterministic. So if the rule set hasn't changed and I asked a question again and again and again, I must always get the same answer. And you'd be surprised how many authentication and authorization systems fail this simple requirement. And it's not a good thing. The things that are about security should be really deterministic. The answer to the question should never ever be it depends, because that's no good. They have to be efficient, so they have to have, a suitable performance envelope and a reasonable payload size. Those two are related, but not coupled to each other. They need to be comprehensible to whoever's doing the maintenance, right? So if you're going to turn over an application system to the end users and say, look, manage your own users and permissions, the harder you make it, the more training they're going to need, and potentially the more brick-thick manuals, and the more likely they are to make mistakes with unintended consequences. And then, in a perfect universe, you can take the entire IAM problem and make it somebody else's problem, or what we like to call in architecture SCP, coined by Douglas Adams. So let's look at this. So here is a bunch of IAM systems that to one degree or another have different levels of functionality and feature. All of these are, to one degree or another, fairly well thought of. All of them, and we'll talk about which ones these fit into which model in a bit, have a certain amount of platform magnetism. In other words, you're unlikely to find Azure Active Directory support if you're in Linux environment, although it is available. Some things are out there in your organization already. Ping Federate is definitely one of those. Oracle Gateway, which is not on here, is one of those. So before you start getting out your sharpest pencil and building an IAM system from scratch, my very strong advice is go ask people who know what you've got already. And I spend most of my life in Azure. So Azure Active Directory and its federation capabilities are high on my list of go-to things because, they're kind of there already. They're already there. I don't have to do any special purchasing or anything. And from the platform I program in, which is mostly C#, there's lots of good libraries for me to use. It just works. And it makes me a happy guy. But, if you're programming in Ping Federate or Okta or whatever, and you have support for that already, and there are libraries for the programming stack that you're using, then by all means, right? So don't write one of these from scratch because it turns out they're really hard to do correctly. And the second thing is, if you trust the people who have written your IAM subsystem, then that's just one less thing that you have to test to exhaustion. Whereas if you write one yourself, you had better test the ever-living daylights out of it all the time. So if you can humanly avoid making one, given there is a literal ocean of alternatives out there in the wild that you can use, including some pretty sophisticated ones like Plain ID. I didn't include it on this list, but go Google around. There's lots and lots of these out in the world. You're way better picking a vendor that you trust and integrating that into your app so that you can focus on delivering business value, which is why you wrote the app in the first place. It's the same logic that I use for everything else security related. Don't write your own crypto. You're not going to be good at it. Don't write your own serializer. You're not going to be good at it. Don't write your own data access tier from scratch. You're not going to be good at it. Use somebody else's stuff. And yes, that adds a little bit of fragility to your solution because you have to trust. But through testing, you can verify and you can make the trade-off between having to build, maintain, and test the daylights out of something your organization wrote, which will probably not be extensible in the future for integration with something else, which is inevitable. You're probably better off making it somebody else's problem. And so for all of the somebody else's problem solutions, there are 5 kind of more this way or more that way sliders. Simple versus complex. Simple doesn't necessarily mean insecure. It just means not very flexible. Free versus costs money. And here we'll put free in quotes by saying that if you've already invested in like Azure Active Directory or Ping Federate or one of the other things, then that's already a loaded cost on your organization. The addition of another app to that complex is probably incrementally cheaper than doing something else from the ground up. And of course, we've talked about your problem versus not your problem. The more stuff you can make not your problem, the better. 100% self-service of user and access control management will make it so that if people call your help desk or support line and you say, have you read our article online about how to manage your own users, recover locked out users, stuff like that, and we've made it all self-service because we've got this great third-party go do it thing, and if you still can't do it, call us back. You'll be a lot happier. Not all of these have the same security level. Social media account logins, Twitter, Facebook, Google, etc., can be quite insecure for any number of reasons, but primarily because you cannot insist on or you're more likely your InfoSec organization can insist on things like password complexity, password rotation, password recovery, strategies, things like that, right? There's just a bunch of stuff that you cannot configure. Whereas in something like Azure Active Directory or Samba or Ping Federate, Jump Cloud, you have a lot of control over setting policies that would prohibit users from, for example, having weak passwords or not using two-factor or multi-factor authorization that would then provide a vulnerability into your software, particularly if they have administrative privilege. And then easy to integrate things are things where there's a library. The library's been around a long time. Lots of people use the library. If you go and Google about it, you'll find a million threads on discussing and implementing it. The library has regular maintenance so that, if you go look at something and you find a NuGet or an NPM or a PEP package and it hasn't changed in 18 months, you probably ought to rethink your choice, because if someone's not actively maintaining it, fixing bugs, adding features, improving performance, improving security, whatever, that is a red flag. If something is really hard to integrate, it's generally a sign that they didn't think it through well enough. And so that it's immature. Even if it's been around a while, it's probably over-engineered to the point where you'll spend more time fighting it than you will leveraging it. And that is a bad thing, TM in capital letters. Keep these things in mind while we talk about the rest of it. I've been thinking about this problem for upwards of 20 years as I've built software for customers. And I have come up with 5 hugely oversimplified models for AuthZ. The length of the bar is the complexity and feature richness of each of the solutions. So we're going to go through each of these models, right? And we're going to talk about the pros and cons. And again, the idea is to provide you a design context from which you can derive requirements, functional and non-functional, so that when you're trying to pick an IAM solution, which may be composed of one or more components, you can make some intelligent decisions about what the criteria should be. Before we do that, we have to talk about logical security models and complexity. And there are fundamentally, as I break it down, 2 different kinds of logical models. One based on set theory, which can be expressed in Venn diagram. And we'll talk about models 1 through 4 in a minute. And the other based on graph theory, where in order to find the effective permissions of something at the leaf, you have to traverse. Typically speaking, it is unusual for set-based thing to have a not or an and. That is, you need this permission and that permission to do this thing. They're typically purely OR-based with a basic rule that says if you're not in a role, if you have no roles, you can do no thing. And typically, newly created users have a default role that is, let me log in and see the home page, just to validate that my account works, that I'm integrated. And typically that kind of generic user role can see the help, they can see the support pages, they can see the announcements, they can see different kinds of things. And then we might have a very simple flat role scheme that says they're data readers, they're data updaters, or they're data administrators, or something really simple. And so the goal there is there's one set, and the membership in that set renders permission. And there can be different sets, and typically, instead of being ORed together, they are mutually exclusive from each other. So I'm either a reader or a writer or an admin, but I can't be all 3. And generally, there's an implied hierarchy. If I'm an admin, I can read and write, but not always. For example, there could be a role called user admin that only allows you to administrate users, but doesn't allow them to see anybody's data. So even with a flat, exclusive set-based approach, which is very simple and easy to maintain, You look at the user, you look at what role they're assigned to, potentially roles, possibly, and you go, I know exactly what this person can do. The next kind of thing up from that, from a set theory perspective, is this idea that identity plus the roles the identity is in is their permissions. So here we might have the ability, we have the ability to add a little more granularity. But again, the OR rule applies. So I can say, let's say I had 3 categories of data. I had data about trees, I had data about animals, and I had data about shellfish. And so I could set up a role that says that I am a tree reader and a shellfish writer, and that's it. And so that your permissions are therefore the effective intersection or of all of the permissions in all of your roles. In other words, you can take the roles and convert them to a permissions list, and then you know exactly what they're allowed to do. And in this case, the roles are typically static. That is to say that we don't allow user-defined roles because we don't have a nice way of assigning permissions to them. Get more about that in a while. The next level of complexity up that stays in the realm of OR-based set theory is identity is a member of one or more groups, and each group has a set of one or more rights. And the summation of all of the rights and all of the groups ORed together are your permissions. And this mechanism, because the rights are defined as their own entities in our entity model, does allow you to make user-defined groups. So we can ship our application with a set of built-in groups, super user, user admin, data user, etc. And then people can make their own groups and assign just the rights they want to those groups and then put users into those groups. So at this level, you can have your end users can start to model their security. And because it's OR-based security, it's still pretty easy to do what we did in models 2 and 3. And I'll explain the difference between models 2 and 3 in a bit. And simply roll through all the groups and accumulate all of the right and then unique that list so we don't have to have any duplicates. And what results is my effective permission, just like above, but now we have more flexibility. So in departing set-based AuthZ, we go to all of the different permutations of graph-based, and there are many. And when we get to that particular slide, we'll talk about some of the more popular ones. But there's 2 things that are true about graph-based systems. One is that permissions must be computed via traversal. In other words, you have to follow the lines of the tree down to the leaf. And now, instead of having a right being you have permission definitely for this, rights can be either permit or deny. So now we're able to not. And combinatorically, we can say that the same traversal of a graph that goes to the same node is effectively an AND. In other words, I must be able to traverse this way and traverse that way in order to have permissions to do that. And there are systems that are like that, and they are really, really powerful, because they allow very deep granularity of object and permissions, but they're really hard to administer, and we'll talk more about that. But typically, when you ask something that's set-based, can this user do this? You get a yes or no answer. When you ask something that is graph-based, can a user do this? You typically get an array of tuples that says they can do this to this, but not this to that, etc., etc. And depending on the system, each of the tuples in the list is either ANDed together or ORed together to get a permissive list, but you get more than one answer, and the answer is more complicated than yes or no. Now, you absolutely need that in certain kinds of systems, and you'll see why in a little bit. But if you can humanly avoid doing this, departing from the realm of sets and ORs, you will be much happier, as well as your users will. And of course, if you have a compliance organization who has to audit what users can do what to whom, they'll be a lot happier as well. The ideas behind each of the 5 kind of categories. So identity is authorization. If they land on my app and I send them off to my third-party authenticator, and the authenticator says, yea, verily, it is indeed Sam, then I can go and look and say, does Sam have the right to use my app? Oh, Sam does. Or Joy, they can just do whatever you can do in the app. Typically things with very shallow permission need that. So that's a pretty useful model for a lot of simple departmental business apps. Sam can use this app or Sam can't use this app. And sometimes that's all that's required. The other thing is with identity as authorization is it tends to favor systems that allow social media IDs, because in those sorts of systems, because there isn't a differential permission scheme to exploit to get elevation of privilege in one of the stride attacks, is elevation of privilege, then, even if somebody impersonates somebody else successfully, the damage they can do is probably fairly limited because there's no elevation of privilege. There is a possibility, if you allow for weak AuthN, which would allow an impersonation attack in stride. And they're typically easy to plumb and fast to implement, and they're really great for things like bulletin boards and blog sites, imaging sites, stuff like that. And if you think about identity as authorization, if you have a publicly facing blog, then they drop on your blog and you do an auth check and they fail the auth check, then they default to be an anonymous reader and they can't do anything. If they fall on your blog page and they are registered with your blog, then they may be allowed to do comments on your blog. If they fall on your blog site and it turns out they're in the list of people who are administrators, then they can create and manage blogs and stuff like that. So identity and authorization, although very simple, is very powerful for a lot of scenarios. But it's hard to extend for things like delegated authorization, sharing resources between multiple users, and if you have differential features above and beyond something really simple. And the general rule of thumb for that is if you make a Venn diagram of what someone can do, and it looks like circles within circles within circles, in other words, vaguely egg-like or like an agate with rings of things, then identity as authorization and membership lists, Joe is in here and not in here, and the different things are mutually exclusive, then identity as authorization works dandy. Identity with IAM built in. So this is one of 2 choices for model number 2. Let's just use Azure Active Directory because a lot of you will know kind of some Active Directory basics. So if I say, gosh, I have an identity and access management solution, and it's got some pretty basic, a person can be a member of a group or can have a role or not, kind of logic. And it's all over there, and it's maintained over there. And you go and you set up all the roles or groups or whatever they want to call it in their particular system. But basically, it devolves down to, for you as a developer, it devolves down to this user has this list of string thingies that I can test to see if the operation I'm trying to do contains on that list or not. It's very easy to maintain. And again, it follows a deny then permit sort of a model. And it's all done outside your app. And all your app has to do is for different operations in your app or different data within your app, do a simple contains test on the user's list of whatever. Doesn't matter what membership, group, role, whatever. Model 3 for that is that for whatever reason, you need to be able to have that same model we talked about in 2, but instead of letting the vendor provided system do it and manage it and whatever, you have some other business driver that says, I'm going to write my own AuthZ. So I'm going to let them do authentication, but I'm going to do authorization. And this is where systems like you can buy or build your way into. For example, Plain ID offers a nice authorization model with a fair amount of power to it. Or you can build your own. And it's typical if you have a shop that wants to have a single place to manage all of this user has a list of these things among a bunch of apps. Or you just don't, your InfoSec or whoever just doesn't feel comfortable having the AuthZ and AuthN functions combined under the same vendor, or whatever. And that's fine because, among other things, the difference between 2 and 3 is typically when a user is redirected to go over to, say, I am Joe and here are my proofs, whatever that may be, right? Password, two-factor authentication, transmutation of the spirit, who knows? That you get back a list of all the things they're part of as part of the payload to that token. And you often see this with JOT token. And you may get other attributes back as well. But particularly if you need to maintain more complex attributes like preferences or something like that, you may want to subsume those into the AuthZ system, and so you may want to DIY it or buy your way into a separate standalone auth, which brings us to 4. At the bottom of this well, working right to left in this little diagram, we have objects or functions that we want to secure, and they're called securables. And the right to do something to that securable, which may be, the classic read, write, execute, delete permissions that you find, a lot in operating systems, or the classic, but only if the object is owned by blah, 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 right? You're going to see this sort of thing. And so, again, now groups are, although you may have some default groups that go with the app, the groups are going to be highly customized so that you can put one or more users in a group with a set of rights. The rights specifically apply to one or more sets of objects. Now you have very granular permission, but it's now a 4-deep traversal. But it's not a graph traversal because, again, the sum total of all of their effective rights is now a tuple of the object and the right or rights on that tuple in a list. So, groups go away. Groups are a convenient management mechanism, but for evaluating whether this user can do something, you first ask, what is the object or function I'm trying to do, or just the name of the securable? Securables can have unique names. And then what actions can I do on it, which are effectively the list of rights. And that's typically a set of tuples of, this user has a list of, dictionary of list of rights is a typical sort of hierarchy. That's very efficient because I can say for this object, what rights does this person have? And if the list is empty, we go none. But again, the trade-off when you go this far down the complexity trail is you're probably going to have to write the business and InfoSec some custom reports that allow them to see the effective permissions for users. But it does allow you to have weird edge corner scenarios. I need Mary to have this list of permissions on all the same things as Joe, except Mary's not allowed to see trees. So I can start with Joe, clone the group, subtract out the tree objects and their corresponding rights, and now I have a new group that is derived from the old group to which I can ascribe Mary to, and now we have Mary can see everything that and do everything that Joe can do as long as it doesn't involve trees. What's the complexity here? Group pollution. So if you're going to do this, you probably should write a little algorithm that goes through the groups at periodic intervals and says, this group and this group have exactly the same effective permissions on the same object, securables. They should be merged. Why? Because this system's performance in this subsystem will entirely depend on how many securables you have and how much your rights complexity is, and then how many groups there are, and then how many groups a particular user can be. But remember, groups go away once a user logs in, right? We're going to do a determination. And it may be that it is impractical for a user to carry around some cryptographic artifact that has their objects and rights in it, and instead they carry around a subset of the common ones, a most recently used list, for example, or just common ones like they can see announcements or whatever, and then every time they try to access a specific thing, it actually does the appropriate lookups to say, can I get to this? And it's important to point out that this still results in a yes or no answer. Can I write this object? Yes or no? And so, again, applying the always use ORs, you are able to have a pretty stable system that is very predictable. And now we fall off a cliff. So we talked about graph-based systems and how challenging they can be. The first thing about it is almost all of them allow the full complement of Boolean operators. So they allow both allow and deny, and they allow you to and rights together or rights together, and of course apply deny by knotting them. You can also have rules like if Jeremy is allowed trees and allowed anteaters, he is not allowed to have either. In other words, the being allowed to have anteaters is okay, or being allowed to have trees is okay, but not both, which is sort of XORy, which can be described as a set of knots and an and. Rather than dive into the mechanics of these, what I have done is I have pulled out 5 of the exemplars, these kinds of models, and given you a link that nicely talks about each one of them with a lot more gravitas than I can. And after you read those articles, if you find, like me, that your head hurts, you may want to reevaluate your requirements. And if you can't, you definitely want to try to buy your way into this problem rather than writing it yourself. So there you go. And so, access control lists, which are probably some of the oldest permissions, the SAP permission model, which is very rich and lots of things are modeled on that model, but effective permission computation is not as easy as you might think. And an awful lot of SAP support, I suspect, is trying to set up users or change their effective permissions when they change roles. And if you don't do that properly, you may have violated separation of duties rules, which are part of GAP or whatever, and you'll be unhappy. ACEs are a little newer than ACLs are, or the SAP permission model. And there's a nice primer. This is the best article I've seen on this. Role-based access control is used heavily, for example, in Azure, Google, things like that. And attribute-based access control is used heavily, particularly in NoSQL and other kinds of storage databases. So if you have some of those scenarios they call out there, you may have to use these. But if you can get away with using one of the other models, you'll probably be a lot happier. My name is Stuart. Thank you for your kind attention.